pen, a chuck label, and I'm going to store a pen in my dictionary with the chuck label. And so it's like having a purse or a bag or a backpack where you have things labeled, and you can throw things in and label them, and you can shout into your bag and say, give me the calculator, or give me the candy, or whatever it is that you have labeled them. You have to come up with the labels, and then you can use the labels to get things back out. And like I said, they're probably the most powerful thing, and they're basically this concept that's generally referred to as associative arrays, which means they're like lists, but they have these keys. And so the associative means the association between a key and a value. Whereas in a list, there's a position in a value, and the position is less powerful and less flexible. Most modern programming languages have this notion of associative arrays. If they don't, they're sort of unpopular, because once you get using them, you're like, whoa, they're so powerful. If you ever find yourself in a language that doesn't have them, you'll freak out. They have different names like property maps or hash maps or property bags, depending on the language you're using, but they all are the same thing. They're key value pairs. So the idea of a dictionary is that, or the idea of any collection is putting more than one thing in, and then the difference is that you have ways of indexing it. So this basically line says, let's make ourselves a dictionary, just like we constructed an empty list. And I want to store 12 into this dictionary, and I want to label it money. And so on the left-hand side, when we use this money, that's the label that we're going to give it. And so 12 is being placed in the dictionary. That's like taking the 12, throwing it in the dictionary with a label of money. 3 is going in with a label of candy, and 75 is going in with tissues. And we say, what's in there? And there's no order to it. And sometimes the order can even change inside of a dictionary, although there are more advanced versions of dictionaries that maintain some kind of order. But for now, let's just not worry about the ordering of them. If we say what's in there, you say, oh, there's 3 things in there. There is 12, 75, and 3, and stored under the keys money, tissues, and candy, respectively. We can ask, using the index operator, what is per sub candy? And that's like saying, hey, give me back candy, and out comes the number 3, which is that. We can update stuff. So we can say, go grab the candy version, add 2 to it, make 5, and then store that back into candy. And so now we see that candy has been set up to be 5. And and so if you look at the difference between lists and dictionaries, they both can have new items added to them. We haven't talked a lot about deleting, but items can be deleted from them. The difference is the indexing mechanism, how we look things up, how we store things, and how we look things up. So we make an empty list, we make an empty dictionary. We add 21 to the end, and we add 183 to the end, and we ask it, and it says, oh, position 0 is 21, and position 1 is 183. We don't see the positions when we print it out because it's sort of implicit. Here we're going to mark 21 with age and stick it in, and mark 182 with course and stick it in, and then we're going to print it out, and there we got course and age mapped. And we can add a 23 and stick it back in age, and that overwrites. So the 21 becomes the 23. We can do the same thing in a list, except we say lists of 0, because in lists the indexing is position, and so this 21 becomes 23. And again, you just look at them and you can think of each of these as pretty much doing roughly the same thing, except the indexing mechanism. The values are the same, but the keys are different. So in lists, the keys are always the position, and you don't get to assign those other than the fact that the order in which you put them in implicitly assigns a position. And in dictionaries, the key is a string. You can actually use other things. I use strings a lot in this lecture, but that's just to kind of keep things simple until you get good at it. You can actually use numbers as the dictionary index, the dictionary keys if you want. But the values are things you put in and manage in those dictionaries. So we can, just like lists, we have dictionary literals. And what's nice about dictionary literals is that they use the exact same syntax as the printout. And so it starts with a curly brace, ends with a curly brace, and then has a series of key colon value, key colon value, key colon value. And this is sort of the associative array bit. We are associating 1 with the key Chuck. We are associating 42 with the key Fred. We're associating Jan and 100. Then we print it out, it kind of looks exactly the same. And so the print statements in Python are nice in that you ask what's in a thing, you show the stuff, and it shows you in the syntax that if you type that into Python, that would be how you do a constant. And if you just say empty array, you see me also do DICT. This is constructor where you say make a new empty dictionary. This is an empty dictionary constant. These two things are pretty much the exact same thing. This is a shortcut to doing this. The empty curly braces is a shortcut to do the construction. So up next we're going to talk about sort of one of the really common applications of dictionaries, and that is counting. So now we're going to talk to you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as, it's a little graph, and there is, how many A's, how many B's, and how many C's, and there's a histogram that says, oh, there's this many of that, and this many of that. And these are like buckets. These are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. But the interesting thing that we're going to solve, just like many of the things in the computer, is we can't just sort of look at the data. We've got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names, one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with one and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see? So what was the most common name and how many times did you see it? That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this and you think, how did my brain look at that? And you're like, okay, what is pretty common? Oh, maybe Chen is common. Oh, Chen, no. Maybe Zhen is common. 1, 2, 3, 4. Yeah, anybody else have? Marquard's got 3, C7. And so you'll notice how our minds, without computers, we just sort of like bounce, branch and bound. We have hypotheses, and then we decide, yep, it's Zhen. That's it, and there's 4 of them. Now, how did your brain think about this as we were going through them one at a time? Well, my guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you'd give that a tick mark. And if you saw XYZ again, you'd make a tick mark. And then you'd keep adding to these tick marks, right? And that's how you would do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you'd sort of take a look at these numbers and you say, okay, that's the most common number, and then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how we're going to use dictionaries to achieve that. Again, instinctively as humans, we just look at the stuff. But if you had a million things, you probably want to write a Python program and use dictionaries. And so this is the idea, and there's 2 basic things that happen. One is the first time you see a name, you got to say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can use the name as the key, and then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding, as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem with dictionaries is like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that